Hey everybody, it's Alex with Engineering Applied. In this video, we're going to be accelerating your career, hobby, or business with this overview of the available extrude tools in Autodesk Inventor. If you're looking for a specific function, check the description for timestamps. If you don't find what you're looking for in this video, make sure you check out the other videos within the Autodesk Inventor series. Also, don't forget to like this video, subscribe to the channel, and turn on notifications so you don't miss out on any helpful content like this in the future. Let's get started. Okay, so to aid us in this overview of the extrude functions in Autodesk Inventor, we're actually going to be developing a mounting fixture for an electrodynamic shaker. And if you don't know what that is, don't worry. What it essentially does is it acts like a speaker. So think of a really big speaker, except the main objective isn't to create sound, it's to create a vibration profile meant to test various parts that you put on it. So in my case, I used it in the aviation industry to test electromechanical components before they go into an airplane to make sure they could perform under the stress of various vibration profiles. So in this case, what you're looking at here is we've got a large square plate, and on the four corners, we have our mounting interface between this plate and the actual shaker itself. So this could take the form of a direct mount to the electrodynamic shaker itself or to a slip table. And if you're not sure what those are, let me know if you'd like me to do a video on those specifically, because I'd be happy to shed some light on what that is for you. But if we look closer at the plate, we have a grid of singularly sized holes. So this is to accommodate a 1032 fastener, and they are spaced 1 inch apart. So our objective here is to create a neutral mounting area for whatever parts that we want to test, so that we don't have to create a bunch of these parts over and over again to match specific parts that we want to test on our vibe fixture. And this is really important for you engineers out there that might be doing this, because you don't want to waste a lot of money and machining time and downtime creating new fixtures and, creating new designs for no reason if you can help it. So this is the practical case I wanted to give you. And I know this is sort of a roundabout way of getting to the extrude tools, but I think it's really important that we relate real life uses for these lessons, because I want you to learn, and I want this information to actually stick so that you can improve your quality of work, whether it's in your career or whatever else it is that you're doing. So let's go ahead and get started here. What we'll do is we'll create a new part file. So I've already got one open here, and we'll just start a new sketch, because we've got to start our background for the actual square profile for the plate. Okay, so I went ahead and drew up a 16-inch square shape, which is going to act as our profile for the plate itself. So we've got that drawn up. Now what do we do? So like I always say in my videos, you want to make sure that your sketches are fully defined. So in this case, we know our sketch is fully defined because the profile is all in the color black. And if I were to go grab any of these sides, it's not going anywhere. It's not going to move. And you'll also notice down here it says fully constrained. So after we've done a good job at making our sketches fully constrained, we're going to go ahead and jump out by either clicking finish sketch here, or we can just right click and go to finish 2D sketch here. And now that we're out of our sketch, we're going to make sure we're in the 3D model tab, and we just click extrude. Now you'll notice that it'll infer the profile that you want to extrude. In this case, we only have the one square, so it knows, hey, this must be what this user wants to extrude. So we will start looking at some of our options in here. And as we progress through this lesson, I'll make sure that we hit all of these options while relating it to this practical use. So at the top here, we have our extrude properties. You can X out of this, but that'll cancel out of the extrude command. So we'll just actually go back in there. Next, you have this little plus arrow. So this will add various tabs to this extrude window. So if you're using iLogic commands or anything like that, or you could go into your favorites. So you have a bunch of your content center resources in here and whatnot. And at the end here, if you click this, we have a few options for how the extrude behaves. This first option here essentially says, hey, when you have your sketch that you're creating an extrude off of, and you press this little plus sign to apply this extrude, but also immediately start the next command, it will keep that sketch visible, or if you uncheck it, it will not. So if I uncheck this, or actually let's leave it checked first. So if I check that, it leaves that sketch visible and it automatically starts a secondary extrude without me having to go in and out of the window. Now, if I was to go back and redo that and just go up here, uncheck that, and then if I hit the plus sign, it exits out of the extrude and it leaves the command alone. So that's what the difference in that command does. So we'll just undo that once again. We'll go back to extrude. And let's take a look here. So we have our hide preset. So when you check that, it hides this little preset option selector. We'll get to that in just a moment. Okay, we also have the single enter to finish command. So what this allows us to do is it allows us to, let's say for example, we wanted to change this distance. So let's change it to 1.5. And if I press enter here, it's actually gonna finish the command and collapse this properties window and exit out of it altogether. So if I press enter once, it leaves the window. But if I were to undo that and go back in here again, uncheck that, and let's change this length to like 1.25 or something, it doesn't matter. If I hit enter once, it confirms the setting in the dialog box, but if I hit enter again, then it finishes the command. So this is really just a preference issue here, so it's just whatever you prefer. Our next area that we're going to look at is, so along this top you have a little navigator. So we have our extrusion menu here, and then we have our sketch. So if we click the sketch, we'll actually see the sketch itself. And this is pretty cool because we can actually edit the sketch on the fly if we want to. So if we want to change this dimension, we can certainly do that from the extrusion window. And then if we're ready to go back to extrude, we can just click extrusion and it goes back into the window. However, we don't want that to be 14. We actually want this to be 16 inches. So we'll just leave it there. Go back to extrusion. Now, the next area is, so we have solid mode active. So to illustrate this, we're going to back away from the square real quick. So I'll just go ahead and extrude that, create a new sketch. We're just going to drop a circle somewhere in space just to show you this. Okay, so you have this other option. So in this case, we'll have a cylindrical profile or any other profile that's able to create a surface on its own. What you could do is you could go up to the solid mode and click that, and it changes to a surface geometry profile instead of a solid body. So that's a quick way to toggle back and forth between the two if that's what you want to do. We're going to just toggle it back. And then this is just our preview option, whether or not you want to see an active preview of what your extrude looks like before you actually confirm the action. So we'll just cancel that. Okay, so we'll actually come back to the preset section in just a moment because I want to go ahead and cover the meat of the extrusion function, and that is the input geometry field. So what this does is it allows us to select the specific geometry we want to use to create this solid body. So here you'll notice it says one profile. We'll go ahead and clear this selection by clicking this little X icon, and you'll notice we're left with our profile. So if you want to select a particular profile, you want to make sure you're within the sketch profile selector, and you'll know whether or not you're in it if you have this little blue line at the bottom. So we currently see the little blue line. If you click it again and it shuts off, you'll notice we can't pick up a profile. If that happens, don't worry, just go back to your selection filter area, click on that. And now when we hover over our profile of interest, it turns green. So we just click in that area. And you notice a section called from. And so this defines it from our sketch plane because that's where we created our sketch. This is where it'll define this by default. However, we can also define other planes if we choose to do so. So if I have another working plane or something in the area in the same orientation, I can use that. But in this case, we'll leave it on the sketch plane. Now, we have our behavior. So this is the next most important area. And this tells the software, hey, I want the solid body to either go in one direction or the other. Or we can also tell it to extrude symmetrically or asymmetrically. So that means that from our plane, we can go maybe like 1/2 inch in one direction and 3 inches in the next direction. And so depending on what you're intending for your design, that could be a favorable feature. But in this case, we actually want to go in the positive Z direction. So its current orientation is fine. And you'll notice we could do a couple different things here. We can go ahead and type in the distance we want to extrude this to. So I actually want this to be a 1-inch plate. So I can type in a 1 and it'll automatically show me a preview of that. Also, I can click and hold this little arrow and I can drag this back and forth. So this is actually a sort of a nice way to manipulate it on the fly and sort of see what it's going to do beforehand. And you don't have to type any numbers or anything like that. Now, you have this little drop down arrow up here. If we click that, it changes our selector style from icons to drop downs or vice versa. So currently I'm in icon mode, which I prefer. But if you prefer more of a consolidated format with your drop down box, you can certainly do that too. And it shows all of the same options just in a drop down menu. We'll go back to icons. Now we have our distance box. You'll notice a little arrow off to the side. This is pretty neat actually, because we can set this dimension based off of a feature dimension or by a measurement. So maybe I want to measure, let's say this line here. Well, this line is 16 inches. So it says, hey, this extrude distance needs to match that distance in the model. So make it 16 inches. It's not so practical in this case, but you'll find a lot of times where you'll say, hey, I want it to be the same length as this other feature. Well, this is a quick way to do that. We'll go ahead and clear that and just set it back to 1. And then finally, you have this 2 option. I'll get more into detail when we start actually cutting holes in the 3D body. So we'll put that on hold for now. Okay, so the next section down is advanced properties. So this is a really convenient way to add a tapered angle in your extrude without having to create a draft or a loft or anything like that. Now, let's say, for example, you're designing a part that's going to be injection molded. Well, depending on the size of the part, you actually might want to put a little bit of a draft or a little bit of a loft angle on the outer profile of the part that interfaces with the injection mold, because if your molded part is a little bit too deep, you could have some issues with sticking to the mold itself. So a way to alleviate that is creating a very shallow taper towards the end of the part so that once the ejector pins start pushing off of the part, when the mold opens up, it helps the part release from the mold itself, and you don't get any sort of sticking or any damage to your molded part. So that would be a handy use for this particular area. And then, so you would add your angle here. So let's drag this out a little bit more just so you can see more of an exaggeration on the angle. And let's say we wanted to add a 1 degree angle to that, or maybe we wanted to, let's do something a little bit bigger. We'll do 15 degrees. Now you'll notice it lofts that angle out. On this side, we can actually click this flip direction and it'll reverse that taper. So that's always there. This iMate button basically infers iMates to the part. So say, for example, you have a pin and bushing that you want to mate together in an assembly. You can use this iMate option as you're extruding these 2 separate parts, define those iMates themselves so that when you import them into an assembly, it automatically mates them accordingly. So that's a really handy tool for your workflow if you're creating an assembly with a lot of the same constraints and you don't want to have to do those individually. And then, so you have your OK, so that confirms the extrude. You have cancel, pretty self-explanatory. And then this little plus sign down here is the apply and create new extrusion. So you saw a little bit of that previously, but essentially what this does is it creates the extrude and then it keeps the extrude option live so that I don't have to finish the command, do a sketch, come back in and then click extrude again and do all this over and over again. It keeps the window and the command open so that I can just do a bunch of different extrudes back to back. So we'll go ahead and change this back to 0. We don't want a taper there. And we want our plate to be 1 inch thick because this would just be a standard aluminum plate stock that we'd order off of a McMaster car or from any other metal supplier that we'd be using at this time. And we'll go ahead and click OK. Now we have the base for our design. So that's our main use of the extrude. Now, something else you could do with the extrude tool, and it might be a little weird based on the CAD software you're coming from, but there's no individual pocket or cut command by itself. What you would do is you would create your profile, select that profile, and then you go back into extrude, and then you have a cut option, which I'll show you in just a moment. So for our next feature, we need to do our 12-inch by 12-inch regular hole pattern for our 1032 fasteners. So what we're going to do is we're going to go into new sketch, and I want to create some reference geometry just so I can keep tabs of what I'm doing with these circles here. So I'm going to just dimension it to 12 inches by 12 inches. I'm going to set this to construction geometry. Super handy. If you're curious about construction geometry and other formatting options, make sure you check out my other video on that. It goes into detail on the differences in there. So we go to construction. Okay. Now our hole size, I've got it written down here. It needs to be 0.159 inches. So this is for our 75% thread for aluminum, for our material, which is aluminum in this case. So I'm just going to pick up this corner spot here, set my hole size. And these will eventually be threaded. So this is the pilot hole size for the thread, just for you folks out there that are wondering, why did I pick this size? If you're unsure of what your thread sizes should be, make sure you check out, there's tons of free drill charts and tap charts online. So there's plenty of good information out there with this info in it. So, okay, we've got our one hole there, but we need to create a regular hole pattern. So we're just going to go ahead and create a pattern in here. So we're going to do rectangular. We're going to select our circle and our two directions. I have a separate video on pattern tools as well, sketch pattern tools. So feel free to check that out if you want to learn more about that. Okay, so we need 13 units in this direction at 1 inch. And then we have our second direction downwards, and we'll do the same. Perfect. So now we have our grid of regularly spaced 1032 holes, which will allow us plenty of flexibility to mount our test specimens to. All right, so now we have our holes generated there. Now we can go ahead and finish the sketch. You'll notice everything is fully constrained. So we go back into extrude. Okay, so you might be wondering, hey, do I have to go through and click each and every single profile that I want to create a cut for in this case? Luckily, we don't. What we can actually do here is we can lasso everything all in one shot, because you'll notice if we zoom in, it'll pick up each individual hole, but it's not automatically inferring that we want to pick up every single feature. And, of course, you don't want to sit here and click through 169 different circles just to create some holes. So what we can do is we could zoom out a little bit and we can just grab everything. And you'll notice it picks up all of 169 profiles that I want to grab. And it's getting it from our sketch plane, which is on the surface. But now notice something here. It actually wants to extrude these as pins outwards. And that's not what we want to do. We actually want to create some holes here. What we can do is we can drag this in the other direction and we get a preview. Now, notice the color difference here. We see green profiles, which signifies an extrude. So it's adding geometry to our 3D space. If we go in the other direction, it creates some red indicators here, which means that we're going to remove material. So that's a very important distinction, and it's something you'll associate, with this as you go along. So that's one way of specifying it. Also, what we could do is I could go down here to the Boolean output operations. And so here you'll notice it's set as a join. So that means that, hey, we're going to create a new profile and it's going to join this new 3D geometry with the existing solid body. It's not going to be two separate solid bodies, which you do have the option to do. And we'll get to that. So next, you have your cut option. Now, if we go to cut, it will automatically know that we want to remove material. And then, depending on the dimension in here, it'll specify the depth. So we actually want to cut all the way through the plate. Well, how do we do that? Well, there's a few ways you could do that. You can specify the distance. So I could specify a distance of 1 inch because I know how thick, the plate is. But that's not good enough, because what if we come back and we want to recycle this design or edit this design to use maybe a 1/2 inch plate, or actually even worse, maybe a 2 inch plate, but now I have my distance set to 1 inch and our intention is to do a through hole. Now it's only going to cut 1 inch deep. So what we can do is we can use our through all command. So it'll just punch through any of the 3D geometry that you have here. But even better than that, you can use the to tool. So if you click to, it'll open a selection box. And, we have our little blue line there, so we know it's active. And we want it to always go all the way to the end of the plate. So we can click the back face, and it will always go to this section of the plate. And I want to show you something here. So if we hit OK, you'll notice that the holes are cut all the way through. But hey, let's change our plate thickness to 3 inches. Well, now you'll notice it still cuts all the way through. It doesn't matter how thick or thin the plate is. It just knows, hey, this user wants the holes to go all the way to the other end. So this is a really good way to ensure your design is more robust and more dynamic. I took a couple of steps back, and now we're back into our window right before we created the cut. And I wanted to explain these other 2 Boolean operations that we see in here. And then of course we have our drop down with our selector style, so we can do the same sort of drop down or icon view. But to illustrate intersect and a new solid, we're going to jump into a new part. Okay, so for our intersect Boolean operation, I went ahead and drew up one cylinder here of diameter 0.5 inches. And I drew another circle that's spaced evenly off of the center line, but it's overlapping a little bit. So think of maybe like a Venn diagram, sort of a shape going on here. So what I'm going to do is I'm going to extrude this, but I want it to only take the intersection between the 2. So what I do is I go to extrude, and you'll notice it's defaulting to cut because it's inferring that I want to go ahead and create a cut through the part. Also, you'll notice if we go back up to this option menu, you have your predict Boolean operation. So this basically just infers or predicts what you want to do with your extrude. So in this case, it says, hey, you have some 3D geometry here. In this area, you don't. I think you want to remove some stuff there. You can uncheck that if you just want to make all of the judgment calls there and it doesn't predict it. I leave it on because it does a pretty good job at speeding up my workflow, and it doesn't really get it wrong very often. So I'll leave that selected. So anyways, if we move down here, we have our intersect. And if we click that, you'll notice it only shows the intersection between the 2 circular profiles. So I could hit OK. And now it just keeps that one shape there. So that would be an example of the intersect tool. Obviously, you're going to be using it for other things. This was just to clearly illustrate it for you. The other option we have here is the new solid option. So if you want to create 2 separate 3D bodies within the same model, you could certainly do that. So we'll just leave that as an extrude, and we can actually bring it out to the same space. Notice here it says join, and when it creates a join, it melds these 2 as a single element or as a single solid body. We don't want that. We want them to be 2 separate solid bodies. So what you do is you go to new solid, and when you click that, it's occupying its own space. It's actually overlapping with this other one, and it leaves that relation there. So if we hit OK and I hover over this, you see it's its own separate body. Now, if we go back and I leave it as join, notice the distinction here. So I just pull it back out to the same distance. We hit OK. Now when I hover over it, it treats it all as one singular body. So that's the distinction between join and your new body Boolean option. All right, we're back to our shaker table fixture, and we are about to create our cuts for our 1032 holes once again. I wanted to draw attention to this other distance command, which is the toNext, which basically takes that command, which in this case is the cut Boolean operation, and it takes it up to the next solid body, or at least to the next face within the same solid body. So if I click that, it's going to default to the same type of operation, but it's using this solid as the reference rather than just the face on the solid. So that's the distinction. Typically, I use 2 because it gives me the most control over exactly what I want to do with this Boolean operation. All right, so we've successfully created our hole pattern for the mounting of our parts that we're going to test, but now we need to create the hole pattern to mount this plate to the actual shaker itself. So what we need to do here is we need to create 4 holes here and it's a very specific hole pattern based on the shaker you're using. So in this case, I already have my hole pattern defined. Don't worry about the specifics there. Again, I can get into more detail about how to design these types of fixtures in a later video, but for now, we're just concentrating on the extrude tool. So first we need to draw up 4 circles in the area that we need it. Okay, so I have my hole pattern set up for the interface between the plate and the table, and it's sized for a 3/8 fastener. And so we'll go ahead and go back to our extrude option because we need to create some through holes, but then we need to create a secondary command and create more of a shallow cut to accommodate the head of the socket head fastener. So first we'll go to extrude. We're going to select the 4 profiles. I'll just click and drag over all of this because it's going to automatically pick all 4 of those up. And you notice it doesn't actually pick up the whole features from before because there's no sketch elements showing or available to create the cut or the extrude off of. So it's really convenient. Now we want to think about what we want to do, what our intentions are for this cut. So we want it to go all the way through the plate, just like these other holes. So we'll go to our cut Boolean option. We'll go to the to command and then have it go to that face. Click OK. Okay, so now we have a through hole, but we need to create a space to accommodate the larger diameter for the head of the socket head fastener. So what we're going to do is we're going to create a cut halfway through the plate that allows the head of the screw to go below the surface so that we don't create any sort of interferences with any parts that we may attach to the top of this plate. This is a huge thing you want to think about. So we're always thinking 3 steps ahead or even more sometimes to make sure that we don't have any interferences or any problems within our test equipment. So we'll go ahead and do that now. So I'm just going to create a sketch on this plane with the diameter for these holes. So we'll go ahead and I'm going to actually project the geometry because I want these centered here. Okay. And actually these 3 were unnecessary. We'll just use this one here now that I think about it because we'll just use that that circular pattern. And then this will need to be 0.688. So this just has some extra tolerance built in just in case the hole locations are a little off, and maybe our machine shop's not holding super tight tolerances. That's something else you want to think about. So we'll just click OK there. Go to circular, click that. We're going to revolve it around the central axis, which is a point in our point of view because the line is going straight at us. Want 4 of those, and then there we go. Now we're fully constrained. Finish sketch. Extrude. Okay. Now this is a great opportunity to talk a little bit about using work planes when referencing your behavior or your cut depth, because in this case, my plate is 1 inch thick and I need to cut down deep enough to where I have enough exposed thread from the fastener on the other side of the plate so it can actually screw down to the shaker table. Now, we have to think about this for a second because we don't necessarily just want to do a blind cut of 0.5 inches just because it works in this case. What if we resize the plate, but we still want to use the same fasteners? We need to have the same amount of thread exposed from these fasteners on the other side of the plate. So what we can do is we can create a work plane and then reference our cut up to that work plane. So what I'll do is I'll cancel that real quick and we go to our drop down under work features and we're going to create an offset. And what we're going to do is, because we need a certain amount of thread showing from this side, which is at least only 1/2 inch of plate taking up a 1/2 inch of thread, and then the rest of the fastener can stick out. We'll start this as our reference side, pull it back a little bit. And so this is in the negative direction. So we want to make sure we're specifying the negative sign here. And we want it to always cut down to negative 0.5 inches from this bottom side that mates with the shaker table. So we go to minus 0.5. Okay, now you see we have our little working plane or our reference plane, and we can go back to extrude, pick up our 4 holes again. Now we'll switch it to the cut operation, but now when we go to 2, we'll have it always cut down to this reference plane that's always going to be a 1/2 inch off of the side that actually matters. This is really important. So now we've got that situated. And now we can just click OK. And now we have our recessed or our counterboard holes. So you'll hear the term counterboard. This is what a counterboard hole looks like. You also have countersunk, which is more of a cone shape recess for those conical shaped head screws, those countersunk screws. So that's the difference there. Okay, so we have our 4 mounting locations to mount the plate to the shaker itself, and then we have our hole pattern to mount the test articles to the plate. So we need some spots to put the accelerometer on, and this is a perfect opportunity to illustrate the final feature within the Extrude option tool set, and this is the preset option. So I already drew up the 4 circles that we're going to use to cut into the plate. So we'll finish sketch, go to extrude. Okay, so going back up to the top here, we have no preset. Well, what we'll do is we'll select our profiles. And let's say that regardless of how thick the plate is, we're always going to only thread it down to, let's say, 1/4 of an inch, right? So we need to cut down to, let's say, 0.375 inches to allow for a little bit of room at the end of the tap. So we'll do that. So we'll create a cut here, 0.375 inches. Okay, now we want to create a preset out of this so that when we go to create more cuts in maybe this part or other parts, we can reference this option from a drop down. So maybe I can set this as, let's do a new preset. So it's marked as 0.375 cut with 0 degree taper. And so we'll just say okay to that. And that's now our preset. If we want to go back to no preset, we could certainly do that, but we'll go back to our 0.375. Now, if you go over to this preset settings, and again, to create a new preset out of your current settings that you had already set, you just press the little plus sign after you set your depth and other options. And then we go to this little settings menu here. We can save the current preset. We can rename it. So maybe we want to rename this to accelerometer pilot hole. So anytime we're creating a fixture in the future and we need to create a pilot hole to tap for our accelerometer placement, we always know that it's going to be to the correct depth that we need and have those correct characteristics for what we're using. So we'll just check that off there. Also we have some sorting order. So this is similar to your file explorer in Windows. You can sort it by various parameters that you see here. And then, you get some new extrude defaults. So maybe you're doing a bunch of these back to back. So maybe you want to use the current preset as your default. Well, you can certainly do that. Here, I leave it on no preset because it's not something that I use too often. It's more on a case by case basis, but hey, you might find a use for it. And, say, hey, we no longer use a certain preset. So maybe I go down in here and I don't want this 1/2 inch cut anymore. I can go to the settings menu and delete this current preset. And now it's out of my drop down. We cleaned it up a little bit and left space for what we actually use. So we can go back to that. You'll notice it goes back to all of our parameters that we want. Okay, so now we just click OK. And there you go. Now we have all 4 of our accelerometer pilot holes using the preset option within the extrusion menu. So that rounds out all of our extrusion tools. I hope you enjoyed this practical example of how to use the extrusion tools, and I hope that it helps you in the retention of this knowledge. That concludes this segment of the Autodesk Inventor part creation module, where we took a look at the available extrude functions. Don't forget to like this video, subscribe to my channel, and turn on notifications to stay up to date on future content that'll help you reach your goals along your journey. And of course, don't hesitate to leave a comment or reach out via my website contact page and let me know if there's anything else you'd like to learn about or see on this channel. I love sharing my knowledge and experience with the community. I cannot wait to see all of the positive impact you'll create out in the world. Thanks for watching, and I'll see you again soon.